We asked 30 students for their score in the mathematics paper. And this is what we got. The first student said 17, the second said 16, and so on. This data is called raw data, which is very difficult to analyze. So we classify or arrange the data and write it in the ascending order. This is what we get. This representation becomes a bit easier to analyze. It goes from the lowest to the highest. Let's erase this and look at a different example. We asked a set of 40 students for their marks in the science paper. And this is the data we collected. Let's try to find the lowest and the highest marks without arranging the data well. The lowest in the first row is 11. There's no number lower than 11 in any of the rows, which means that 11 is the lowest number in this set. What about the highest? In the first row, it's 18. And there's no other number greater than 18 in this set. The scores are between 11 and 18, both of them included. And some of the scores may have occurred more than once. There are different ways to organize the data. Here, we tried tally marks to see how many students have scored the same marks. So let us make two columns of the scores and tally marks for each of the scores. The scores range from 11 to 18. We write all numbers from 11 to 18. The first student says 17. So we put a vertical line next to 17. The next student says 16. So we put a vertical line next to 16. And we continue the process of adding vertical lines. Just remember that whenever we come across a number that appears for the fifth time, we cancel out the first 4 tally marks to make the count of 5. So when we come across 18 for the fifth time, we use a slant line across the 4 tally marks to make it 5. We continue this process till we exhaust all the values in the data. As there is no student who scores a 12, we put a horizontal line to denote no occurrence of 12. Next, we represent the tally marks in numerical form. For 11, it would be 5 plus 1, which equals 6. Since 12 does not occur at all, we write a 0, and similarly, we fill the rest of the column. What are these numbers called? These would be called the frequencies of each of the scores. 6 is the frequency of 11. It means that out of 40 students, 6 students have scored 11 marks. None of the students have scored 12 marks. 7 students have scored 13, and so on. Now here's something you need to know. If we find the total of all the frequencies, we should get the total number of students. Sum of all these numbers does give us a 40, and that is written as summation of f equals 40. This sign is called the summation and means sum of a set of numbers. In this case, it means sum of all frequencies. So how would we benefit by making such a table? What are the kinds of questions that we will be able to answer swiftly? What is the highest score scored by a student among these 40 students? It's 18, the last number in the first column. And what's the lowest score? It's 11, the first number in the first column. How many students scored 16 marks? It's the frequency of 16, which is 7. Here's an interesting one. How many students scored more than 15 marks? Try answering it in your notebook. It means how many students scored 16, 17 or 18 marks. It will be the sum of these 3 frequencies. It will be 7 plus 6 plus 5, which equals 18. 18 students have scored more than 15 marks. This representation is called an ungrouped frequency distribution. Ungrouped because we are considering one score at a time and not a group of scores. When would we need groups? Think hard. If the scores ranged from 11 to 100, this method would not be suitable as we would have to make 90 rows. That's when we would have had to make groups. We will look at grouped frequency distribution in another video.